welcome back to my channel. So as you have seen, if you are following the playlist, so I already covered most of this is playlist, or let's see, is the GitHub. And the next step is to give some practical application of these, let's say, algorithms. So I have, as you can see, I have covered the basic algorithms, for instance, linear regression, logistic regression, support vector machine, and advanced, let's say, methods like random forest, XGBoost, and gradient boosting. And all of these already explained in a very easy way with real examples. So in today's example, in today's video, I will say, I also covered the neural network. So I will try to go with you with linear price prediction example with XGBoost. We will build a model that predict house price using real data award. All, and I can show you the data set is taken from the Kaggle, and you can see it has these features, and you can see here's the sub address, rooms, number of rooms, the price, and the method. I don't know if it's really needed to be included, and the type of the house. Is it only bedroom, house, town, house, and etc. And the distance from CB. I don't know what is the CBD, because maybe it's a city. And property count, so the number of properties that exist in this region, and the bathroom, if you have a car sports, and etc. Most of these, let's see, columns or features will be not included, but I will just show you how the basic, how to go through this, how to let's see, I start with any project. So as you can see, this is our, let's see, table of content. We will try to import the backend libraries, loading the data processing. So data is not, let's see, ready to be fed into a XGBoost algorithm. And we will try to analyze the data, split it, train and test, model training and model prediction. And I will show you what is the important features in using the XGBoost, and how to make a prediction, and also finally how to save the model for later prediction. So because I have already imported these, let's see, this is our let's see, lesson. So I will try to fill all of these, but in the beginning I have just attached these important libraries. So I will try to import pandas. Pandas is really used to manipulate data. So reading data from CSV files, reading from data from text file, from any file. Also, you can load it from any source you want. And numpy, it's, you can see, somehow it's for operations. And this is matplotlib. So to visualize something, the selection, select the features, train, test, split. And the XGBoost, I'm using the regressor because it's also used for classification. And because I'm using the regression, I need to evaluate the algorithm using R2, R square score, and mean square error, of course. And now some features are not, let's say, numerical, so it's categorized as you have seen in the unit. So we need another type. So for this, I need to make them as, let's say, label encoder. So make them numbers. So let me just run this in the beginning. And here I'm reading the data from using CSV, because after importing the panda, you can read the CSV file. Now I will try to show you what is the inside the data. So let me close this, and you can see here address, rooms, type, and as I said, so label encoder, it will try to encode this somehow, and make them numbers. And let me now, I'd like to pre-process the data. So what are the pre-processing steps? So first, let me show you what are the available, let's see, avail, available columns. So this dot column dot values. So you can also like do this columns and then to list. It should be to list. Should be also the same, but this will save it as a list. As you can see here, now we have it as a list. Now, so if you would like to drop or remove any columns, so imagine, for instance, I need to remove, for instance, method. So I'm just, let's see, I have a feeling that method is not, let's see, relevant to my data set or my experiment. So what I can do is removing the data set, I mean the columns. So I will see data frame is equal data frame did drop. Now I will write the columns name, put it in the list, and let's see, I will see method, then let's see re, region name, and for that you need also to add access is equal 1, so it's a column name. So not only the values, also the whole column. So let's see if you can see now. Let's just add this again and see if I still have the method. As you can see, it's not drop columns method. So what is the error here? And not exist. It was here. What do you mean by not exist? Interesting. So let me cancel this. So when I have done this, it showed me a method. Now it's not showing a method. Cool. Rooms type price. Let me show this values. Yeah, method is here. And also it's here. So when I try to remove it, let me just do one stuff. If I see this, okay, it's working now. Okay. So now I have removed the method and the, let's say, the region name. Now if I do this again, I will get error because already removed. See, because it's already removed. So what I have to, okay, I got it. So I have to do is go here, start with the dataset, and of course you can do it like dataset new, I mean data frame new, and you can have, so for this you don't need to read, if you now run it again, it will save, because it will just make another copy from data frame, and data frame still has have these attributes. So now let's go to the second point, which is encoding the columns or attributes. So we can do features. Let's see. Encode, it's equal label encoder. So now if you see the I still have only the I need to convert this I make it as a categorical. So let me just see data. Let me just, because I have done it in Indeed with this data frame, so I will maybe make some mistakes. If I remove this, let me just say encode data frame. Oops, why it's capital data frame. Now you can type. So this it will apply only for this data for this column. Type encode dot fit transform. Now you need also to add the same data frame type. So this will only apply for this column. So let me now select some features. Let's say I need to define some features. Define some feature for the experiment. So let's see features I have. The most interesting features are rooms, of course, type, then postcode, distance to the cities, to the downtown, maybe, and property, that is capital, property count. For this, now after this, I will say data free clean is equal data free. Let's see features. Okay, now after this, some features. Let me just run this and see if the data it has. Let's see, some features will be having, let's see, some null values. So how can see it's, we need to get the information, data frame.info, I think .info, and you can see here not null. Okay, so all the values are here, so nothing is missing. Let's see. Okay, now I have this data clean data data frame. But let's see, in case you have some oh, so we need here to clean, not null. Okay, so as you can see here now, if in case you would like to have you would have some null or none, so you need to drop the missing values. So how to do this? Data frame clean is equal data frame dot drop drop now. So if it's missing, let's see. You can see now this already done. And if let's see, I also now need to select the features. So as you know, the features, it will be for the training. I will have data frame, data frame, data frame clean. I will have the features, and for the class label or y it's equal data frame clean price. Let's have a look. For instance, if you need to print some data, but let's say you need to print some the very first values of y. I think y I don't know if you can hit okay. Data clean has no prime. Okay, yeah. Sorry for this. So I need also to include price. So now I will start from scratch. Sorry for this. Now dropping this. The price is not included. Why? Price. It's working, but I have no idea why it is showing error. But you can see this is the price. 1 million or 14. I have no idea how much is this. Now let's now add some analysis to the data. So let's see after importing the plot, I will create figure. Let's see figure size. Figure size is equal to 885. Just only this. And now we will use this SNS packages dot. Now you can have the heat map for the for the correlation between the parameters. X dot correlation, which is it X? Yeah, it's X, but small x. Dot correlation. Now you can just see numeric only is true, calculating only for the numeric values. Now annotate is true, just to have you to show you the labels, and the color should be, and you can see the values. You can see the color map, see, and maybe it's not needed. Or just cool warm. And for this, let's give it a title. PLT to title features correlation. Then BLT dot show. So now it will show us the correlation between our features. So you can see here, room, let me just show. So if you see the room, the correlation between these features, room and room, it's 100, it's 100%, or let's say 1. And you can see this color here, this red color, it means it has a good correlation. And in this blue, it's the correlation, let's see, is neglected, or let's see, there's no correlation. And if you see the distance, and postcode, it has some correlation. And the distance, yeah, distance as postcode, because it's identical matrix. So you see, this is 111, and the above part is it's equal to this one here. And you can see, for instance, 6. So for instance, property count, it's 6.06, and it should be property count to which feature. Let's see, to the price. And if you see the price, it's this one here, property count to the price. So this and this is the C, this and this is the C, and etc. Now you can also show the distribution of the data. It's help you to see how the data is distributed. So again, we will use this labs histogram plot. Now we see Y distribution. So I don't know what are the, let's see the other parameters. Let's just see this. And plt dot title, price distribution. Sorry if it's wrong. Now plt dot let's see, x label. I need the price. For the y, plt for the now we need that y label should be for the frequency. Now plt dot show. Let's see how it should. You can see, for instance, this value here, the values between 0 and it's not 0 indeed, it has 1000, and most of the values, let's see, is in this range here. And big values are not, let's see, it's far away from the distribution. So this is the distribution of your data here. Now we need to split the data into training and test. And you can see x3 then x test, y train, y test. So splitting first the training x, then the training y, the y. In the beginning, it x split x, then split y in both categories. Now I will use this function train split. I will add x, y, then the size of the test size of the split, let's see, 0.2. So it will split the data 80% for the training and 20% for the testing. Let's see, for instance, print training size dot dot size. So you can see how many input, or let's say color, rows in this, in the training, and you can see how many this. This is just to show you how many samples in the training and how many samples in the testing. This is only for the training and testing. And now we need to train this with XGBoost. By the way, if you are not familiar with XGBoost, I have done a good video on this with the real example and with really step-by-step example. So I'm quite sure you will understand it with 100%. So model X regressor. So it has many parameters, and for this I would like to copy these parameters because I'm not let's see aware of this. So you can see here, this is number of trees, and this is the learning rate, max depth. It is, for instance, it will have each tree will have maximum three levels, and subsamples, column samples by tree, and random state. And let me just see model dot fit x3 and y3, of course, y3. Okay, so we have done this. Now let's do the training. Okay, cool. I have this wrong, this error before, so I think I know how to handle this. Let's go to here, clear this output, and it's trying to print the model, but it's not able to do it in this Jupyter notebook. But let's try now. Now you can see it's working. And now I need to evaluate the data. So I will see y predict is equal model dot predict, and I will put the x test, only the x, not the class label. I will only put for the prediction. I will just need the features without the class label. Now this will predict some values for this. Let me just show you. Dot head. Okay, I need to print this because it's not the last one. Print, and you see this is the, what's this? The price is included. No way. What's this? Let me check. XY X test. Let me just see the head of this. Print xtrain dot head. No, it should be indeed removed. So see, let me, I have done wrong. This is not wrong. Yeah, let's see, I added myself, sorry. So this is my wrong. So let's see, in the beginning we need to clean. Let's see, yeah, we need firstly this one, this we will remove. Okay, extremely sorry. So these are features. Now I need to data. So now drop the data. Now I will see. I will see X. Where's X? Let's see, cleaning this. Now I will see X and price with a video. Now it should work. Sorry for this. Now you can see the price is not included. This is the indeed the goal. And you can see here, let's see the head, the X training. Now we have predicted some values. Let's see what are the values here. Print dot head. So it's not anymore a data frame. Let's see, just print y values, and you can see this is the predicted one. Now we need to compare the predicted with the original values. So for this, as I said, we will use mean square error is equal mean square error, which is already imported in the beginning. Now we need to add the y predicted values, y predicted. Let's see just without this y predict and y test. And you can see the mean square error, it will be big value indeed. And the last one, I need R², which is R2 score. I will just, of course I will need the same. This is calculating the error and this is evaluating the the algorithm. So this will give you a value between 0 and 100, 0 and 1. And we will see if our model is a good to predict the values or not. And let me just print mean square error is the mean square error. Print. Now I will see print R² score R2. So let's run this and see. Let me just remove this because it's. So you can see that this is the mean square error, and this is the square root. I mean R². So this means the model is not, let's see, uh, performing well in this data set. It depends on one. What are the input? What are the feature that I used in this, for instance, experiments, so I have just used this, and also on the parameters of the XG regressor. So now let's say you need to visualize this PLT scatter plot, scatter, and you need x and y, PLT dot x label. Let's see, x label is the predicted, or we can actual price, but we need now to move this here because we need this to be in the x axis, and the y will be predicted price, but we also need to change it here to y, and PLT dot title should be XGBoost algorithm price prediction PLT dot show. Okay, let me just pause the video, and because it will take much time, and I will copy the others code. So this is the show you the predicted values. This is the actual price, and this is the predicted price, and this is the line to split the data. So as you can see, it's not, let's say, a good fit. So a good fit, that the distance between each point should be minimized, and the optimal one, all points should be in the red file, in the red line here. And let's see what are the most important features in the XGBoost model. As you can see, the postcode, distance, and etc. Now let's see make a prediction. So this is our model, and we need now to make a prediction. So I have done example form type, post span, post code, distance, and etc. So now let's see, the predicted values will be 1 million. A lot of money indeed. Okay, and this one, it will save the model as a pickle file, and this will be saved in your directory, which is where you save it. Now the next step, sometimes you would like, let's say you are planning to use this model, so you can load this model with this function here. Then you will have the sample data, and as you can see here, the prediction of this data, it's almost, I mean, it's the same, because of course we use the same data and use the same model. Okay, that's it for today, and if you like this video, please subscribe to my channel, like the video, and thanks for watching, and see you next time.